like and share this video. So this comment says, can I properly explain the causes of rising dampness in a building? That's why I'm here today. I want to use science and engineering to better explain the causes of rising dampness in a building. Science is the method of obtaining knowledge through observation and experimentation. Mark the word, observation and experimentation. And engineering is the application of scientific, mathematical and technological knowledge to design, build, reform structures, machine system and processes to solve real world problem. So the rising dampness right now is a real world problem. So let's go to observation. So when you observe a natural stone or hard rock, you can see that they don't allow water to pass through them. Hard rocks, you can see. So based on that, engineers have come and then developed what come with cement, Portland cement, which contain gypsum, clinker, limestone, clay, tri and tetracalcium. These things made it that when you add water to it, it solidifies back to cement. So they come out with grades that 1:1 or 1:half will give you a strength of what? 250 Newton per millimeter, which is almost like a rock. So these two here will give you that grade. So they come out with these grades, concrete grades, that help us to withstand some of these things. So when you add these things here, this is what they give you. So these two here become what? They mix together to bond with this one with the same strength, so that we can get a crushing strength of that, which is almost to rock, that does not allow water to pass through. But the reason why we have crash chippings is that buildings comes in various form, various models. So these crash chippings help us to modify whatever design that we want to modify on a building. So come here and then look at this, and then you see what we are doing today. When you look at this carefully, you can see that the rock, you can see how it's flaking. The rock is still, let's say the chippings is still intact. But what is supposed to bond this to get the strength of almost this, that does not allow water to pass through, is not there. It cannot even hold it. These are some of the things that happens in the building. So it allows water to pass through, it absorbs water, and then up to a level where it can evaporate into the atmosphere. And look at this concrete here. So whenever your walls are wet, this is what your iron rods also go through. You can see it clearly. So this is it. You can see that this one too does not bond the concrete very well. You can see it, and it is flaking off. This is it. So let me show you something. So it is this same engineering that made it possible that bridges are built across the sea, across rivers. Bridges, the columns, they mount the column or they construct the columns in the sea and then the rivers, so that they can build overhead and all that. So mostly when you see overhead and bridges, they do not suffer what we suffer because they have the best grade of concrete. They don't depend on bitumen or this thing, even though they have additive that they add to the concrete, but they don't compromise because these things are there. You can see how caked cement look like. This is a caked cement. You can see. So this is how caked cement becomes like a rock. So when you have the best design, best mix design, this is what we are supposed to get in our building. And we have grade of concrete for everything that we are supposed to do. But today, we are not doing it. Most of the engineers or people are afraid to use the right people for their buildings, and they suffer it. So when you look at this and you look at this, you can see what is happening here. You can see clearly that this does not have the best design. These are some of the things that we are facing. So when you look at this building here, you can see that this is the first floor, and in most buildings you can see even third or fifth floors are suffering this blistering. If it is basically salt that we blame, all of us know that rainwater does not contain salt or does not contain alkaline, because the pH level, the pH of rainwater is about 6.5, which is almost neutral. When it's at 7, meaning the water is neutral, so 6.5 pH basically means that it doesn't contain anything. So how does rainwater affect this thing? So whenever it rains, the walls absorbs water, and based on what I explained, that is what happens over there here also. And so you can see that where the column is, you can see that that place looks more distant because the concrete here is not solid, so it absorbs more water. These are the things that happen. You can see the lines. So these are the things that happen. So let me go to this place and then explain certain things to you. So when flakiness is happening, this is how it looks like. And a lot of people thought that, oh, they have something that they apply on the skin. That is why I'm not against using bitumen and other damp-proof materials, but make sure that you have the best grade. When you go to, let's say, civil engineering, where people are constructing bridges and all that, using those DPC and then DPM, they don't even use DPC at all. They are using bitumen painting. It is not that they are depending on it. I don't even know the reason why, but they are like nanso in case. So they don't really depend on it, because when flakiness starts or the issue of dampness starts, this is what happens to your walls. So it is not that, oh, I have a graviator that will stand this and that. There won't be bonding because it is the wall that is flaking, and there's no chemical, all those homogeneous chemicals that they apply on the skin of this in thinking that it is, by time flakiness will happen and then it will become like this and fall off. So that is it. That is what we need to know. That is what we need to know in our building. And another thing is that when you look at this place closely, imagine that this is your foundation. The beam here is your foundation. And then you use a DPC on this column or DPM on this column, on this section or at this level. What happened to the columns? The column also becomes what? A channel which the walls can absorb water, just like this one. You see the mark here, just like this, above it, and then spread to this side. So the next column also do the same thing, and then they come over the level where you use your DPC. I don't know whether you guys are understanding this. If you don't understand, you can comment so that I properly explain that to you. So these are some of the things that happen when sometimes some people use DPC, DPM, paint bitumens, and then at the same time they are facing whatever they are facing again, and they are confused, they don't know what to do. So this is basically how rising dampness issues are. Thank you very much. Follow for more.